Okay, let's look at how to name compounds. Let's look at IUPAC Nomenclature of Organic Compounds. All right, let's look at how to name compounds. What are the key factors, or what are the rules when it comes to naming organic compounds? Now, IUPAC means the International Union of Pure and Applied Chemistry, and it is a useful system for naming of organic compound. All right, IUPAC means the International Union of Pure and Applied Chemistry. All right, so now in conventional naming, carbon atoms are numbered on the longest chain, starting from the end, which is closest to the branch chain or substituent. All right, I'm going to explain this practically when we start to name organic compounds. Now, let's look at other rules. All right, let's look at other rules. Now, other rules of IUPAC nomenclature. When you want to apply the rules of IUPAC nomenclature, it says select, number one, it says select the longest continuous carbon chains as the root hydrocarbon chain and name it according to the number of carbon atoms present. I come again, it says select the longest continuous carbon chains as the root carbon chain and name it according to the number of carbon atoms present. All right. Now, rule 2 says number the carbon atoms in the root hydrocarbon from the end, which give the longest number of substituents. The substituents can be alkyl group or radical or halogens. The halogens are denoted by prefixes. That's fluoro represented with F, chloro represented with Cl, bromo represented with Br, and iodo represented with I. All right. Now, the third rule says the number of each substituent may occur more than once. Now, there are some substituents, all right, that are fixed into the organic compounds like methyl, all right, chloro, the halogens, and every other substituent halogens or radicals are put in. They might occur more than once. So when they occur more than once, they are named according to the number of times they are repeated. All right, that is, if they occur 2 times, we name them di. If it occurs 3 times, we name them tri. If it occurs 4 times, we name them tetra. All right, very, very important. Now, the fourth one says if the substituents present in the compound are more than one type, the substituents are named alphabetically. But when they are mixed substituent, the inorganic member is first named. All right. For instance, you can have an organic compound that has methyl and ethyl. All right. And E comes before M. So when you're naming them, you start with ethyl before methyl. All right. Because they are 2 substituents, but you name them alphabetically. All right. Take note of that. Now, the fifth one says in selecting and numbering the longest continuous chain, the closest to the functional group is given preference over substituents. In selecting and numbering the longest continuous chain, the closest to the functional group, take note of this, functional group, closest to the functional group is given preference over substituents. All right. So when you have a functional group in an organic compound, you make preference to it over substituents. All right. When you want to determine the longest continuous chain, right? When you want to number and take the longest continuous chain. Now, let's see how we can apply all these rules to naming organic compounds. Now, the first one we're going to look at is going to be this. Now, look at here. You have C by the side. Up you have CH3 below. By the side you have CH3, you have CH3. Now, how do you name this kind of compound? How do you name this? Now, first of all, I'd like to tell you that you can also write this. All right. Another way you can write this is like this. So this is C. This is C, carbon. This is another C. Then this. Now, this C is this C. All right. This C now is this C. Then you have H3. That means 3 hydrogen atoms, all right, attached to that carbon. And then you have another C here, so which is this. So this is 1, 2, 3. And then now you have two substituents, right? CH3, CH3. Now take notes, right? I want you to take notes. Take note of this, all right? Take notes that CH3, all right? CH3 is methyl, all right? CH3 is methyl. So anytime you see CH3, all right, as a substituent, you know that they are referring to what? They are referring to what? Methyl, all right? Methyl is what we are referring to. So this CH3 attached here as substituent, and we have two of them, one up and one down, all right? So this is CH3. Now this other CH3 was just your normal carbon with its hydrogen atoms, and this one too. So what I'm trying to say is that this can also be written like this, all right? So, but let's come back to this. Now, when you want to name organic compounds, you look at the longest chain, all right? Your numbering, how you're going to take your numbering from the longest chain. Now, if I decide to move left like this, all right, this will be my first carbon, all right, this will be my second carbon, and this will be my third carbon. Also, if I decide to move, if I decide to move right, so this is right, this is going to be my first carbon, this is going to be my second carbon, this is going to be my third carbon. But if I decide to move left, all right, if I decide to move left, all right, take my direction left, all right, like this. This is going to be my what? First carbon, this is going to be my second carbon, and then this is going to be my third carbon. All right, so if we're moving like this is going to be our first carbon, this is going to be our second carbon, this is going to be our third carbon. But if we're moving like this is going to be our what? First carbon, second carbon, and third carbon. Now, if you check, whichever way you move, if you move right or if you move left, you're going to find out that what? They are still on the same numbering, all right? So, meaning that for us to name this compound now, we have taken it that this substituent, all right, although they are on the same carbon, but they fall on number 2, all right? So, that's the first thing to take note of. Then, how many parent carbon do we have? All right, that's another thing to take note of. How many parent carbon do we have? We have 1, 2, 3. All right, these carbons here are only substituent. If you come here too, if you want to use this too to understand it, all right, this is carbon, carbon, carbon. These are the parent carbon. These ones are just substituents, which is called methyl. So the same thing I was explaining. If I decide to move right here, this will be my first carbon, this will be my second carbon, and this will be my third carbon. If I decide to move left, it will be my first, my second, my third. So they both fall on the second carbon. All right. So now, how you are going to look, what is the parent name of this organic compound? What's the parent name of this organic compound? Now, how do we know that? We're going to look at how many parent carbon do we have. We have 1, 2, 3. It's still the same here. We have 1, 2, 3. All right. And when you have an organic compound that has a parent carbon of 3, that tells you that you're looking at what? Now, we know that when it's 1 is met. All right? We know that when it's 1 is met. When it's 2 is et. When it's 3 is prop. All right? When it's 4 is boots. When it's 5 is spent, and so on and so forth. All right? And so on and so forth. All right? So when it's 1 is met, when it's 2 is et, when it's 3 is prop, sorry, do not write this. Then when it's 4 is both, pent, and so on and so forth like that. That's how you have it going. So since we have 3 carbons here, 3 parent carbons here, right, as you can also see on the other diagram that you can express this as, it means that we're dealing with what? Propane. All right. Why is this propane? This, looking at this organic compound, this is what? A single bond. All right. And we know that alkane is a family that has what? Single bond. One of the ways you identify an alkane family is by their single bond, because they have single bond. All right. Their functional group is single bond. That's a very good way to identify them. So now, So we know that our parent name, all right, parent name is what? Propane. All right, we know that our parent name is what? Propane. Now, so to finally name this compound, what's it going to be? So the naming, what's going to be the naming of this compound? The naming of this compound now is going to be what? Is going to be what? 2,2-dimethyl propane. 2,2-dimethyl propane, because you have two substituents which is called methyl, and you have two of them on the same two, all right, on the position of two, on the position of the second carbon. So it's going to be 2,2 because they are on the position of the second carbon, and because of we have two methyls, it's going to be di. Don't forget, when we were looking at the rules here, we said what? That the number of each of them may come more than once. They are named according to the number of times repeated, and 2 is di, 3 is tri, and 4 is tetra. So in this case, we have just 2, all right? We have what? Just 2 of it. So that is what? Dimethylpropane. So this is our answer, all right? Now, let's look at another compound. Let's look at another compound very briefly. Now, let's look at this other compound. Now, we have this. We have CH3, we have chlorine here, we have CH, we have chlorine here, we have CH, we have CH2, we have CH3. Now, what's the first thing I look at? I'm looking at the single bond, right? Good. That means it tells me that this is an alkane family. Then, what do I look at again? I look at what is the parent name, all right? What's the parent name of this organic compound? Now, I'm seeing carbon here, carbon here, carbon here, carbon here, carbon here, all right? So this is 1, 2, 3, 4, 5, all right? This is 1, 2, 3, 4, 5. So I know that the parent name is what? When you're dealing with an organic compound that has 5 carbons, all right, it means 5 carbon atoms. It means you are dealing with what? Pentane, all right? Pentane, all right? 1, 2, 3, 4, 5, all right? Now let's look at the numbering, all right? Because we have substituents, all right? Now, if we move to the right, this is going to be our first carbon, this is going to be our second carbon, this is going to be our third carbon, this is going to be our fourth carbon, and this is going to be our fifth carbon. All right? Now, if we're moving to the left, this is going to be our first carbon, this is going to be our second carbon, this is going to be our third carbon, this is going to be our fifth carbon, fourth carbon, this is going to be our fifth carbon. Now, if you look very closely, if you move from right, this is going to be, this is the first substituent you have. This is chlorine. This is a substituent you have here, chlorine. It's going to fall on the position of the second carbon. But if you move from the left here, this chlorine now, which you confront first, is going to fall on the third carbon. So which one is more closer? The one from the what? From the right. So this is how we're going to take our direction. This is where we're going to move through. So we're going to move through the right to get our longest chain. So this is going to be what we're going to take the right position, all right? So this is our first carbon, our second carbon, our third carbon, our fourth carbon, our fifth carbon. Because if you move from here, you find out that the substituent chlorine falls on the third carbon, all right? But if you move from here, you find out that this substituent, this chlorine here, what is on the second carbon. So we better move right. Taking the right direction is best for your numbering, all right? So we know that the parent name is what? Pentane. Now, how do we name this compound? We have two substituents. We have chlorine, all right? So don't forget that we said Cl is called chloro, all right? Chloro. Don't forget that. So now, what will be the naming of this compound finally? What will be the naming of this compound finally? What is going to be the naming of this compound? Now, we have two substituents, chlorine, so we know it's chloro, and we have two of them, all right? And one is on the second position, one is on the third position, all right? So it's going to be what? 2, 3, because we have a 2 and we have a 3. Then what? Dichloroethane, 2,3-dichloropentane. All right. So this organic compound, to name this, it's called 2,3-dichloropentane. All right. Now, I can also write this just so that you can understand better. This compound can also be written like this as C, 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 C. I have 1, 2, 3. I have, for this now, you're seeing CH2 now. I have 1, 2. All right. I have what? Cl. I have what? H here, up here. And I have what? Cl here. And I have H down here. And I have C. I have H. I have H. I have H, which is hydrogen. All right. So I'm trying to tell you that this can also be written like this, but this is a long form of writing this. Right. This is a condensed form of this. This is the condensed form of this. All right. So to name this organic compound, the name is going to be what? 2,3-dichloropentane. So that is how you name organic compounds. Make sure you like this video, share this video, and hit the subscribe button and also the notification button, because I'll be uploading more videos of naming organic compounds. We'll be taking study on alkane, alkyne, alcohols, and many parts under organic chemistry. Make sure you like this video, share this video, and hit the subscribe button.